All right, guys, let's get this going. You will see today's topic, and you're probably maybe thinking, why are we wasting a day on this? This is something I've gone over a ton already this year. You probably started talking about it in middle school. Well, there's two reasons why I wanted a day of Pythagorean theorem. One is I really don't think we have that great of a grasp on it. All right, because sometimes when I ask, hey guys, I got a right triangle where I know two sides, how do I find the third? And then I hear crickets. All right, so we needed a day of this. And there's another purpose for Pythagorean theorem other than finding a side. What's an obtuse triangle? A triangle where one angle is bigger than 90. So the only way you guys would know if a triangle is obtuse is if I gave you angle measurements. Everyone in agreement? Yeah. Well, today I'm going to give you side lengths, and you're going to tell me if it's obtuse or acute. Just by their sides. Forget the angles. We don't need them anymore. Just by the side lengths. That's the second half of today. All right, first half, let's just make sure we can apply Pythagorean theorem every single word problem here. All right, first thing we got to go over, when can I use Pythagorean theorem? It is not a all triangle theorem. Right triangles only. And we know a squared plus b squared equals c squared. A and B represent your what of the right triangle? Legs. And C would represent the hypotenuse. Now, I still have an issue with this, even in this honors class. How do you identify in a right triangle where the hypotenuse is? Please don't tell me the longest side. I can't stand that because sometimes you aren't given the side lengths. You're just given a plain old triangle with a right angle in it. Where is the hypotenuse then? Phoebe? Wherever the right angle is, you look across the street from it, and there's the hypotenuse. All right, do not go by side lengths. All right, so let's actually start using it here. Parallelogram, and I'm going to use Pythag. You're darn right. You're darn right. We mix as much geometry together as we can. Find the perimeter. Perimeter tells us all. How do I find the perimeter of any figure? Add up all the sides. All right, well, I started you off with one side length. One side length is? Whoa, buddy. Oh. Okay, let's ask this again. What is one side length of the parallelogram? I got 9 from here to here, and then 2 to here.
It's on the same line, so wouldn't it stay? No, if it stretched the entire way, it'd be separate from it. It'd be like further down. All right.
Next up, you should now know another side. It's a parallelogram, Molly, so what do you know about opposite sides? They're congruent, so applying the property of parallelograms, the other side is 11. We got to work on the other two, though. Any way I can find this side now? Pythagorean theorem. I need somebody's help to set it up. 3, help me set it up.
2 squared plus 6 squared equals c squared.
Yep. Four plus 36 equals c squared. Oh, here we go. Simplest radical form if necessary. Oh, it's necessary. It is necessary. Breaking down 40 for me. 14, got it broken down. 2 radical 10, got it. So that side is 2 radical 10. What about the opposite side to 2 radical 10? Also 2 radical 10. I love this problem. Pythag, properties of a parallelogram, and now a little radical addition. You can't combine all 4. Can't combine all 4. Give me something that you can combine, but not all 4. 11, something I can combine.
You can combine the 2 11s.
Yeah, I can and get 22.
Yeah.
What about the 2 radical 10s? How about the 2 radical 10s? There we go. 4 radical 10, yes. As long as what's underneath the radical is the same. And then, hey, kids, can I combine what's left here? 22 and 4 radical 10. Does 22 have radical 10 in it? Sorry. That's it. All right, that's it. It's a great question. A lot of geometry in there. We're okay. Perfect. Next one, where maybe Pythagorean theorem might be used. To get from point A to B, there's our boy. He's going to be making more of an appearance this semester. Big Al must avoid walking through a pond. To avoid the pond, here we go. He must walk, so he's going to avoid this pond. He's got to walk 35 meters south. South. Down, thank you. And 41 meters to the east. Okay, because it's south and east, that's how I know what is formed here. Well, for now, a right angle. To the nearest tenth of a meter, how many meters would he have saved if he could just walk on that water? Well, how many did he walk already? By avoiding the water. By avoiding the water. How many? He's already walked 75 meters by avoiding it. All right, well, what if he could have walked across it? Well, let's find out. He could have walked across the pond. All right, well, let's find it. Can I set something up here to find that distance? 4, set something up for me.
34 squared plus 41 squared equals 6.
Great job. I'll go to my calculator and do it with you. Just curious. Good teaching moment here. What are you doing with that number? I'm not done with the problem. Is this number right here the distance he saved? No, so you're not rounding a darn thing yet. All right? You are not rounding anything to the final answer. So I'm keeping, yes, all of this here. 53 point. I'm going to cheat. Did I copy it? Okay, let's go back here. That's because I got to get on the arrow. Let's try that again. Paste that sucker in. There it is. I probably could have just saved time by writing it. Okay, so how can you find me the distance he saved? So save distance. I'm going to take that 75 he walked and subtract what it could have been if he could walk on water. And to the nearest tenth, 5, nearest tenth, what are we looking at? There we go. Big Al, 21.7 meters he could have saved. All right. You will see more and more of him as we proceed in this unit and the entire year. And then at the end of the year, you'll actually see his identity. Here we go. One more Pythag for you. All right, little setup here. Help me set this one up. I have a right triangle. I know 3 of the sides. Let's roll. 23, help me set this one up.
8 squared.
Yep.
Plus, in parentheses, x minus 4.
Thank you for the parentheses. Yep.
Equals x squared.
Thank you. Nice job. All right, guys. 64, that's not a big deal. Here's where I start cringing. How are you going to attack this beast here? What is your game plan to defeat that beast right there? Because it better not be distribute the 2. Come on, act like you've been in algebra before. Square everything in there, like x squared plus 16. Not x squared plus 16. What do I have to do here? Hey, guys. Hey, what's 3 squared? How do you get in that? 3 times 3, right? What's 4 squared? How do you get in that? 4 times 4. X minus 4 squared. X minus 4 times x minus 4. And you're going to have to double distribute, FOIL it, whatever you called it last year. Do not distribute the 2 as it's an exponent. You can't distribute it. Come on. Seven. Let's roll. 64 plus 16 equals x squared. What can I still combine on that left side? 64 and 16. Yes. That'll give me plus 80. And I know some of you may have started sweating at the beginning of this problem because you're like, oh, factor. Nope. Why am I saying no to factoring? Because when you get it equal to 0, either side, what's going to happen? You're going to subtract one of the x squareds and they're going to cancel out. So what am I actually left with? Negative 8x plus 80 is equal to just 0. Don't panic. Solve for x. All right, so what do you want to do here? Here you go. 1, what do you want to do here, Sarah? Add the 8x and divide by 8. X equal to 10. Perfect. Questions? All right, because of time's sake, and this was more of an honors level topic here, I'm going to skip the whole Pythagorean triples. It's not needed. It was just if you guys see 3, 4, like if you see a quick little snippet here. If you see 3, 4 on a right triangle, you don't need to do Pythag. It's automatically 5. If you see 6, 8, guess what the hypotenuse is? 10. Any multiple will work too. All right, so I just wanted some famous ones. If you're ever doing a problem and you say, oh, I see 3, 4 are the 2 legs, 5 must be the hypotenuse. It's a famous triple. Okay. What I really need to get to is the next page, which is it obtuse, acute, or a right triangle? Just by knowing the sides. Just by knowing the sides. All right, guys, I have number 1. I have 3 sides, 9, 12, and 15. I want to know if it's a right triangle, acute, or obtuse without knowing no angles. Not going to give you any of the angles. Here's how I use Pythagorean theorem to find out what type it is. I take the 2 smaller sides, which would be 9 and 12. I plug it in the Pythagorean theorem. 9 squared plus 12 squared. I don't put the equals in because what I want to do is compare a squared plus b squared to the value of c squared, 15. So can you guys find out what the left and the right side should be, and then we'll talk. So I get 81 plus 144 equals 2. What's the value on the left side with a squared plus b squared? Number 9, a squared plus b squared, that value? 225. So does everyone see? The a squared plus b squared value is equal to the c squared value. If they're equal, what's the only time where a squared plus b squared equals c squared? What type of triangle? A right triangle. So if they come out to be equal, that's what we've been doing all our lives here. I must have been dealing with the right triangle. Okay, what if they're not equal though? Here we go with numbers, letter B. So 10 squared plus 11 squared, compare that to 13 squared. What did you guys get for the a squared b squared side? 18. A squared b squared side? 221. Which side's bigger, the c squared or the a squared plus b squared side? If that's the case, if the a squared plus b squared side is bigger, I am going to have here's your cheat sheet up above, an acute triangle. Okay, if a squared plus b squared is bigger than c squared, that will form an acute triangle. If it's reversed, if the c squared's bigger, then it's obtuse. Okay, but this would be acute since the a squared plus b squared side is bigger. One more. And you know how much we love the graph. So I'm sure you know what's coming up here. What type of triangle is this? Acute, right, or obtuse? I'm going to save everyone the dreading of this. One group, one side length. So you only have to do distance once and then copy down everyone else's work. We got what, 2, 4, 6, perfect. All right, let's go XZ. I'm going to assign to these two groups right here. You guys got the distance of XZ for me? Back two groups right over there. You guys have YZ. And the remaining two groups have XY. Find the distance, please, so we can compare the sides. Take a peek around, talk with your group if you want. Just make sure you got the right spot going. Okay, write them down if it wasn't your responsibility. How about that XZ group? What do you got for the distance of XZ? Radical 13, there we go. How about that YZ group? 2 radical 5, yep, good. Thank you for breaking down 20. And how about that XY group? Woo, all right. Let's figure out, let's test what type of triangle it is. What are the two smallest sides up here? Because that's going to be my A and the B. My two smallest sides up here. 21, you're up. Two smallest sides. Okay, so we're going to do, ready everybody? Radical 13 squared plus 2 radical 5 squared. And we're going to compare that to the square root of 29 squared. And see which side is greater. Okay, who's going to do the calculations here for me? We'll go somebody. No, maybe not today. 15. Square root of 13 all squared. 13, you just drop the radical. 2 radical 5 squared. Again, hey, make sure we're putting it in parentheses. Don't leave that squared hanging out there without it. What do you got, Ansley? 20 and square root of 29 squared. $29. All right, everyone, ready? Looks like left side I have 33, and to the right I have 29. So my a squared plus b squared side is bigger, so that makes it 18. What type of triangle? 18? Acute triangle, yes. If you need graph paper, you might want to grab a couple slices over there for tonight.